welcome everyone to this evening's meeting of BCS Spa. There are plenty of seats near the front. You don't need to push yourself down to the back. Just for the purposes of those who haven't been here before, you know where the emergency exits are, this way and turn to the right. And the toilets also turn to the right and turn to the right again. I'd like to order up pizza whilst Derek is talking, or other meals. So could I just have a quick show of hands? Who has any special dietary requirement and wouldn't like to eat standard pizza? Any gluten-free? Any halal or kosher? No? So I'll probably just order 2 or 3 large ones, and Derek would like chicken. So chicken. Yeah, there's a chicken and chips option. So who'd like that? Okay, we'll just sort of the 2 then. Right. Thank you very much for that. Derek very kindly offered at the end of a previous talk that he'd do his talk on software estimation, and having done a lot of software estimation and miscalculation in the past, I'm all agog to hear what he has to say.
Yeah, thank you, Ingmar. Okay, right. So a bit about me. So formed a company in '83, wrote compiler front ends, back ends, code generators. This was back in the days before Intel dominated the market. There were lots of CPUs, lots of languages. Got into source code analysis, and then industrial research in software engineering. So all the slides are on GitHub, so you can go and grab all the slides. They're all there now. That's how you can get hold of me. There's my GitHub account's not there. We'll get to it in a minute. So I wrote this book, Evidence-Based Software Engineering. You can go and download it there. It's free. You can go and get the PDF and all the data's there, or the code's there. Or you can go to Amazon and you can buy a copy. There it is. Welcome to come and have a look. So yep, there it is. So all the slides are on GitHub. You can go to my GitHub account, there it is, and go to the talks page, and they're all there. There's my book, and I write a blog called The Shape of Code. I talk about this kind of stuff. So I'm talking about cost estimation. So I guess you can basically divide cost estimation into 2 kinds of work, where you're quoting for external work, or you're doing it internally for planning. So I'm going to be talking about the history of estimating software, various models, and the data, and how accurate it is. And I've got lots of data to talk about. And then really 2019 is when things changed. And so I'm going to be talking about post-2019, which is where the big step jump occurred. So what are the incentives for estimation? Well, by the way, I like lots of questions. Please feel free to dive in and ask lots of questions. Otherwise, I'll just rattle through the slides. So if you're bidding for work externally, you're competing against other people, other companies who are bidding on that work. So obviously you're going to underbid, aren't you? Everyone does that. You're going to bid low to win the contract, and then when the client asks for unplanned work, you can put the price back up. So I'm very surprised when people say, well, people always underestimate. Well, of course you underestimate. Who's going to be stupid enough to overestimate? It's a crazy thing to do. And in fact, everybody's in this together, aren't they? This is a quote from the Planning Association. The company wants to do the work, or managers within the company want to do the work. And if you quote too much, then they might not get permission from their bosses to do the work. So they're kind of quite keen for you to not quote the full price. You want to get the work, so you want to underquote. Really, everybody's in it together. Everybody underquotes. It's a kind of an understanding that's going on. So that's for external work where you're bidding. Internally, if you're working on a project and your manager comes up to you, and what are the pressures on you to quote high or low? If you quote high or low, are they going to go somewhere else? Who else have they got? You work for them. So if your manager comes to you and asks you, how long do you think this will take? You might try and impress them by quoting low, or perhaps you want to be conservative and you'll quote high. So there are different incentives depending on whether you're bidding for work and you might not get the work compared to actually doing the work yourself. And you're going to have to do some work. Yes, okay. So, okay, sorry about all this. So what's the return on investment for investing in estimating? People seem to think that if they ask you for an estimate, that it's free. But why would you work for free? I mean, how much work are you going to put in to estimating something? You're only going to, depending on whether you think you're going to get the job or not, you're either going to be low, you're going to spend half an hour on it, maybe a day or two, depending on how big the contract is. Function points is a particular form of measuring estimates. One function point is reckoned to be between about £1,000 and £1,500 typically these days. And these things you see at the end of tucked away, those are the sources I'm citing. So I'm citing the figures from that particular paper. This paper estimates that a function point counter, of course, done the work, can estimate between 200 and 750 function points a day. So that's a sort of like £250,000, £750,000 contract. They can do that estimate the size of that project in a day. And there are people complaining, oh, that's too expensive. We're going to put this engineer out for a day on a £250,000 contract. So there are companies who are just not willing to invest in estimating. And there's real little data on the cost of estimating. If you find any data, please let me know. Does that disappear eventually?
I think you're going to dismiss it.
I have to dismiss it, do I?
Yeah. Yeah. This is like one of those fairground things, isn't it?
Yes. Okay.
Oh, if you just click on that screen again.
Yeah. Okay. I'm not seeing the titles. I'm not seeing the titles. Oh, well, never mind. So, pre-2019, most bids for these are the studies. The available data will involve mostly bids for external work, small amounts of data. And if you're going to build a model and do research on estimating, you need data. So what kind of data do you have? And most of the available data pre-2019 was data on external bidding for contracts. All of them, and they were very small. Virtually all of them were less than 100 rows, i.e. less than 100 projects. It's ridiculously small. And the tasks they were estimating were expected to take some number of days, some number of weeks. Those were the sort of kinds of jobs they were estimating. And people built models to make predictions. Given these options, how long would you estimate that it would take to implement this functionality? Those were the kind of things that people were building. And what happened was the early researchers created the series. And then when later researchers came along, they used the same data and they were more interested in publishing papers. They would come up with a mathematical technique and they would try and show that their technique was relevant to industry by using it on the estimation data to make better estimates. And it was really a big game. And there's a lot of I call it fake research. That basically researchers are taking these tiny data sets with some fancy new algorithm and producing a paper. And they're only really interested in producing a paper. When you talk to them about estimating, they don't know anything about estimating. They want to talk about their fancy new algorithm. And post-2019, the majority of the data is for internal work rather than external work. So all the data that arrived in 2019, after 2019, involved internal projects. Data contains thousands of rows, so several orders of magnitude more data. So we can finally start building good models. But the tasks were taking a few hours to a few days. So the tasks were much smaller. You probably guessed it was agile work. So they're much smaller tasks. And the models that were building to understand what's going on, not make predictions. You can build models to make predictions if you want. But the published work is looking at building, trying to understand what's going on. And most researchers are still interested in just publishing papers.
Is the gig economy within the scope of that comparison, or is that too small level?
This analysis is about software. I guess there are people working in the gig economy doing software. I don't have any data. If there was some data out there, that would be great. You think people working on 5R and stuff like that, who are quoting sort of like £100 to implement a web page or whatever. That would be interesting to get hold of that data, but I don't know any sources of that for that kind of data. Yes, that would be good if there was some. So historical, the slide is about historical models. So most of the models date from the late 70s, 1970s. That's when people suddenly thought, oh, perhaps we ought to try and figure out how all this estimation art works. And a couple of people actually built some models, or come up with some ideas or theories. And essentially, since then, everybody's been copying them, copying these models, tweaking the models. There haven't been any sort of major revelations since. What to estimate, the traditional one, of course, is time and cost. And there are a few people looking at staffing. How many people do you need to hire? And the theory, obviously, when something new like software comes along, you say, well, what theory should we use? And they adapt existing theories, like the theory of manufacturing. So the idea of software was like a factory, and you'd have people on a production line producing software, and all the various manufacturing models were used as a basis. Of course, that doesn't apply. The ideas of hardware manufacturing don't apply to software. So there's lots of red herrings in there. And the input parameters were usually lines of code. People would say, well, if we're going to write about 10,000 lines of code, how long is it going to take to write 10,000 lines of code? Yep.
So with the manufacturing one, is that Lean and Six Sigma? We talk about different.
Well, this is traditional production level manufacturing. Lean and Sigma came later. With Agile, I'm going to say something about that. But the sort of the manufacturing models from the 50s and 60s we're looking at. But software is not like manufacturing in the sense manufacturing is about duplicating a product. And when you duplicate software, you just copy it. You make a perfect copy. So in that sense, software is not like manufacturing, it's like design. So the models are essentially using a lot of new products. They're doing something similar to what's been done before. So if you know a product, the previous version did 50,000 lines, you'd say, well, perhaps this one's going to be 60,000 lines, and it's a different application domain, and you plug those numbers into a model, and it would say it's going to take however long it's going to take. And the data was coming from military and NASA projects. The military, large organisation, they were very interested in reducing costs, taking control of their projects, and they had enough muscle and economic power to say, yes, we want you to go out, and they paid for researchers and they gave them some data and stuff, said, yes, we want these models, we want to take control of what's going on. So the drive for this was military and NASA. And they were large projects. There were many companies involved, so there was lots of documentation, and they were interested in high integrity. So with NASA astronauts and stuff going into space, it had to be very reliable. So they wanted software that was very reliable. So that's the background to the estimation model. So this kind of is very different than kind of industrial projects, which tend to be much smaller. People willing to accept fewer. It's not so much high integrity. They like high integrity, but they're not willing to pay for it. And there tend to be only one or two companies involved. So it's very different kind of background to what you might call industrial research. So these models were coming from a completely different perspective. So a couple of models. Kokomo is probably the most well-known model. You'll see that mentioned everywhere. Academic background, Barry Boehm, wrote a book, 1981. Very good book, actually. It's widely cited. He had all his students writing papers and he went to conferences and everyone, it's really widely cited, yeah.
1981 edition wasn't the first one, was it?
Yeah, it was. What's certainly the one I've got.
He'd done all his research at
TRW.
Hughes Aircraft, starting from about 1967, wasn't it?
He did, yes, and then he went into academia. And that's when he published his book.
Right.
And people are quite surprised when I say there's 63 rows of data. He basically overfit 63 rows of data. That's his data, 63 rows of about sort of 30 different attributes. There's one evaluation, there's my evaluation of his data. As I'll say later, it basically doesn't work, his model doesn't work. And then he came out later on where people get saying, well, your model doesn't work, came out Kokomo 2, and that has 161 rows of data. Not 161,000, 161. And then this guy, Putnam, who was a colonel in the army, was it the Air Force? Anyway, his model was very nice, actually. He sat down from first principles and he came up with a differential equation for how this is a staffing model. That was a costing model. This is a staffing model. How would the various factors, and it was a Rayleigh differential equation. It's a nice piece of theory, and he was working on the assumption that individuals are kind of just cogs in the process. So if you've got a very large project, which in fact kind of stuff that they were analysing, hundreds of people, then people are kind of interchangeable, and so it's a kind of like large project model, and it kind of works. He set up a consultancy. His model is not so well known because he worked in industry and he sold his consulting service and his training service. He didn't have lots of students promoting his model. So it's still out there. There's a guy called Parr who wrote a paper, which I think is only cited in 2 sources, 3 because I cite it as well, who improved on Putnam's model. But Parr never went into academia, never went into consulting. And so virtually nobody knows about his model. And that's the most sophisticated model out there. And it's an improvement on Putnam, but nobody knows what it is. Unless you read my book, then of course you know what it is.
And what was that called again, Parr?
Parr was the author. That's his second name. I don't know, I can't remember what his first name is. Anyway, if you click on that link or go, it's cited in my book. Just go. Yeah. So anyway, right. But he has the same assumptions. He assumes it's a large project, hundreds of people, everyone's interchangeable, and it's a staffing model. So that's the historical. So say something about the public data sets. That's a 2023 paper that reviews all the data sets. So you see how small these rows are. Elbrecht in 1980, 24 rows of data, that's it. Kokomo 63, NASA had 18 rows. Ooh. China came out to that with 499. Yeah. Oh, this is really quite. The DAX data. This is the American DoD. They used to sell a tape with lots of data on for $50. Then they stopped selling it about 15 years ago. I have not found anybody who has this data. I've emailed the original authors, I've emailed DAX. If I see someone, DAX mentioned in the paper, I email the authors of the paper. So this data, it appears to be lost. I don't know where it's gone. I'm sure somebody somewhere has it. And I've emailed lots of people and say, oh, sorry, we don't have it anymore. Yeah, so it's public data that's gone. But you can see how small this data really is. It's a joke really that people do machine learning on this data, which is unbelievable. They publish hundreds of papers have been published on this. The Rome Air Defense Center was the primary research lab of the US Air Force, and they did some fantastic work in the 70s and 80s. And the Air Force officer's master's thesis in the 70s and 80s contains more data in their appendix than all the research, all the academic researchers put together. Huge amount of data. And then in the mid-80s, they outsourced it all to universities. I've got a blog post where I say the fall of Rome and the ascendancy of ego and bluster. The ego and bluster because it all got shipped out to academia. And it was called the Rome Air Defence. So it literally was the fall of Rome. They were doing great work and then fell. And there are confidential data sets. Every now and again, a researcher will know someone in a company who will let them have access to the data and they'll publish a paper. The data is confidential, so it won't get released. The USDD, they have Defence Technical Information Centre. They publish lots of reports. You can go and download them. Lots of interesting stuff there, but you more or less have to know what you're looking for. They have a cost assessment data enterprise where they collect all their cost data. And there's a subset, SRDR is a software research data, something or other. But if you're a DoD contractor, you can access this data. I'm sure it ought to be available under freedom of information, but I'm not a US citizen, so I don't get to submit freedom of information requests. But if anybody watching is in the US and wants to submit freedom of information, they have lots of interesting software cost data and estimates. NASA have data. Getting data out of NASA is virtually impossible. They don't care. An ISBSG bunch. They get companies to give them data and then they sell it to you. They're a non-profit and they sell data. You'll sometimes see papers that if you're an academic researcher, they'll lend you subsets of the data to write a paper on, and then you have to say thank you very much, these people, and we lending us these data, and you're wonderful. Of course, the data is confidential, so you can't see it. So that's the confidential stuff. Yeah. So please, people in the US, submit freedom of information requests and get some of that data out there. They have lots of data. So this is a photograph of my copy of Boehm's book, Barry Boehm's book. This is how people used to publish their data. It was published in books. So I took this photograph of Boehm's book. This is the 63. Oh, only goes up to 47, sorry. Actually, it should go to 63. There you go, 63. So that's a copy of his book. So he published the data into over 2 pages in his book. And that traditionally is how people publish data in the 70s and 80s. They'd write a book, and in the appendix to the book, they would publish the data. And there you can go, there are sites that have typed that all in, and you can go and download it and so on. And all those previous, all these 24, 18, 81, they're all published in books, and you can go and get the book, and there's the data in the back. And that's how they did it. The data was so small you could publish it in a book or a paper.
Can I ask for comparison?
Yes.
How big when you say that data sets on software project estimation are really small, like a few tens to couple of hundred rows, which means few tens to couple of hundred projects that have been surveyed. How big are these kinds of data sets for other industries, like hardware industries? I can't imagine Intel to have really much more than a few tens or maybe a couple of hundreds projects, because that would be roughly how many different chips they have designed and developed.
Depends what you mean by a project or sub-project. I've certainly seen data sets containing thousands of rows in various industries. So in some industries it's available, some it isn't. I've got a couple of slides later on where I talk about other industries and how they estimate things. I haven't looked too hard, so I imagine some of them are like software where they don't have very many, and some of them do have lots. For instance, if you go to the European Union tender website, they've got a few where people are tendering on projects. They have a few hundred projects that are software related. So that again is quite small. But this data from the 70s and 80s is small because and if they only ran a few projects. And for instance, the DoD, this DoD cost assessment, I know they've got thousands of projects in there over many years.
Okay, thank you.
Certainly, if you know of any estimates from other industries, I'm always interested to compare how them with software to see how industries vary. I'll say something. Where we go? Yeah, so Kokomo accuracy. I'm only concentrating on Kokomo because it's widely cited and it's got poor accuracy. There's a study there. I do this. Kokomo 2, 161 rows, so 98 extra rows. It's not public, so people can't compare it. It's also overfitted because they added more data and they added more parameters to the model. So they sort of kept overfitting it by adding it. And there's no public evaluation. Barry Bohm's group published papers. And here's one here, someone's PhD thesis. It's kind of interesting. He talks about everything except the parameters to the model. It's like they don't want to reveal, because the original model has inaccuracies. And so the later model, some of the parameters have changed quite a bit, which raises all sorts of questions. And when you read the later papers, they kind of dance around the fact that the new model is very different than the old model. They don't want to admit that the old model actually wasn't very good. Anyway, so unfortunately he died about 6 months, a year ago. And his group's website, universities, typically when someone leaves or dies, the website just completely disappears. So his group's website is gone. And so you have to go onto the Wayback Machine to find it. Yeah. So I was talking about lines of code. So if you're going to estimate a project and you've got a formula that says, well, tell me how many lines of code you've got, and I'll give you an estimate. That means you have to estimate lines of code. So the problem has shifted from estimating cost to estimating lines of code. So you're still making an estimate. So you might say, well, how good are people at estimating lines of code? And here's some data where people have estimated the lines of code, how many lines of code they think are needed to implement some functionality. And this is how many lines it actually took. And you'll see how poorly they've estimated lines of code. So in a sense, this undermines the whole idea of these formulas. The formulas assume that you can accurately estimate lines of code. And if you can't accurately estimate lines of code, then the models are just not going to work, are they? And the other thing that completely sinks the models is that different people write different kinds of programs for the same functionality. So if I was to give everybody in this room a task, write a program to solve this problem, would you all create programs that contain the same number of lines? Probably not. So this particular task, developers were asked to write a program to implement a particular problem. And that was the number of lines of code that different programs contained. And this is the number of programs. So about 150 programs, sort of had 50 lines of code in them. Small number of programs only had 14 or 113. So you can see that with different people or different programmers, their programs will contain different numbers of lines of code. So again, the idea of estimating how many lines of code a particular problem is going to take, the answer depends on who's going to program it. So this whole idea of task estimation using lines of code is a non-starter. It's just not going to work. And in fact, when you evaluate the models, they don't work. You're not going to expect them to work. This data came out after all the models were built, but people are still using the models. They say, oh, we'll estimate lines of code. No, it's just not going to work. So it's no surprise that the models don't work and they're not going to work. They can't work. It's just human variability. So fake research. So there are hundreds of papers, over 100 papers fitting those tiny small data sets. I wrote a blog post, software estimation is mostly fake research, is my most popular blog post. Everyone's always citing it and downloading it. So who does real software engineering estimation research? Business schools. People in business schools have got contacts in industry and they can get good data. Unfortunately, they can't make the data public, but they do they write good papers, or some of them write good papers anyway, because they have good data and they know how to do statistical analysis. Magna Jorgensen, virtually single-handedly, the guy doing good experimental research in software estimation. He runs experiments. He pays people money to do professional organizations to do studies. He does studies where he pays multiple companies to develop the same software and he compares them. So that's his website. His papers are definitely worth reading. He's the main guy. And a few people, sorry, yeah.
I've got another question here from Arthur. He says, I wonder if the end goal is to estimate the time and cost, and the lines of code is only a proxy. How did the time to write one line in the 7-line solution compare to the time to write one line in the 113-line solution? So the problem in the histogram.
Yeah. Well, people build models out of what they can measure. They can measure lines of code. Now, how long does it take you to write a line of code?
In my experience, the more elegant and condensed the code is, the longer it takes. But it's not that 113 lines of code would take 10 times as long as 13 lines of code to write it. But there's certainly multiplication.
You might see a 100-line program, but did the person who wrote it, created it, write 100 lines, or did they write 200 lines? And then they threw some away, they rewrote it, and so you're only seeing the final result. You're not seeing the 200 lines that they wrote to get down to that eventually turn out to be 100 lines. So yeah, I mean, lines of code is a terrible metric. It's actually, well, in some case, but it's easy to measure and it does correlate with various things, or rather longer lines of code.
The company that I was working for in the 1980s, we actually translated Barry Beam's model into an Excel spreadsheet. And it was in multiple stages. So you'd first of all estimate the lines of code, and then you'd apply the various fiddle factors that Beam finds in his book to come up with an eventual sort of staffing and cost estimate. And we soon found that lines of code wasn't easy to estimate and wasn't accurate anyway.
Yeah.
So we substituted something called function points. So you guess how many.
I'm going to talk about function points.
Okay, right. Go ahead.
So if you want the details and the references and the citations, section 5.3 of my book, just the whole, I cover everything. Okay, so this is Agile. It says Agile at the top there. So we're moving into more recent times. So we've covered the pre-2019. We want to forget all that stuff. Yeah. So Agile, you break stuff down, work down to small tasks. You have a backlog of tasks. There are different kinds of or methodologies for Agile. I'm not going to talk about them. So you have the unit of measurement. The unit of measurement might be no estimates, function points. I'll say something about those. Story points and time seem to be the main ones. So no estimates is very popular. Very popular with developers. So developers hate estimating. They have inaccurate estimates are known to be inaccurate, they're misused, unpopular with developers. So let's not do them. And there are lots of agile consultants out there who are promoting no estimates movement. And the reason they get away with this is the demand for developers outstrips supply. And if the developers are unhappy, they leave and go somewhere else. And managers are paranoid about losing their developers. So they're willing to let their developers not estimate. And so, yeah, let's have fun at work. So it's crazy, but people get away with this. And you can only get away with this because demand outstrips supply. I was wondering in the current recession, with developers being laid off, whether or not managers would have the feel more confident about sort of saying, right, you're going to estimate. I don't care if you don't like it and you're not going to be able to find another job because jobs are scarce. But actually, it turns out every meetup I go to, the speaker finishes by saying, oh, and we're hiring. So lots of small companies are still hiring developers. Developers can still easily change their jobs. So if you force a developer to hire to estimate and they don't like it, they can get another job and you've lost somebody and you've got to go through the hassle and the cost of hiring a new developer. So no estimates is a thing. Yeah.
If someone truly wants to learn about their art, you would think they would want to get in the rhythm of doing estimates.
Yeah.
And as Emo said earlier, the more expert a person is, usually the shorter the code, the better the code. So someone who has lots of lines and then they do to 200 is maybe a false sense of putting money to it because people inflate that.
Yeah.
So I'd rather have an expert pay for that and know that 6 lines of code is going to work compared to many lines that maybe not.
But I know plenty of experts who hate I hate estimating. I'm not claiming to be an expert, but there are plenty of experts who hate estimating as well. So it's not, oh, you become an expert and then you suddenly start loving estimating.
I wasn't making that analogy, but thank you for that. Yes, okay.
So I guess it takes some of the companies I know who make people estimate, when they hire people in, the culture is estimate. And that when people come in, join the company, they start by estimating. And it kind of like everyone does it and they kind of get used to it. And certainly other industries make people estimate. So certainly you usually find that when software companies are estimating, they're usually closely associated with an industry where the industry practice is to estimate.
That helps also in other skills of scope and, you learn more about how you want to shape.
Sure. I think estimation is about it's the planning process, isn't it? So the estimate's inaccurate, but it's helping you create the plan. It's making you think about what's going on. It's like with Agile when when you're estimating, you're supposed to chop things down into small tasks. So if you come up with a big estimate, it probably means you haven't chopped it down into small enough components. So function points, that says function points at the top. So function points are introduced in 79 by Albrecht, and they highly correlate with lines of code. And there are lots of ISO standards for them and different ways of counting. And you can become an accredited function point counter. And the training is designed to produce consistent results. So if you are an accredited function point counter for one of these techniques, and you have 2 of them, and you give them ask them to estimate the same work, they should come up with the same number of function points. So they should both come, if it's 12, one says 12, the other one should say 12. So the idea is they should be consistent. And in fact, if you look at the data, they do tend to be consistent. They follow the procedures and they end up with a number. But what's the connection between the function point and reality? So they follow the procedure, they all agree it's a 12, but when they implement it, where is the data showing that the function points are accurate? And there's only one data set that I know of, and you go and talk to all the function point consultants, and they say, oh yes, we think it's accurate. Well, of course, they're selling their services. So where is the data? Well, I have found some. So this is the number of function points, and this is the cost. So these are overestimates, these are underestimates. And when you do the analysis, it turns out that they're about as accurate as estimating time. I'll come on into a minute and show you the accuracy of. So based on, from 2 companies, one with 149 and one with 492 projects, the function points have about the same level of accuracy as other techniques. They aren't some sort of magical extra, at least based on these 2 data sets. If there's anybody out there with other data sets would like to show me that I can publish how accurate the function points really are, if you use the right data, I'm very happy to see it and analyze it for you.
So that's just a median line, is it? You said over and under. And
That's a regression line.
that was it? Oh, okay.
There's a grey line, sorry, there's a grey line there, which unless you come close to the screen, you can't see. Sorry about that. That grey line there is estimate equals actual. That red line is a regression fit, which is slightly tilted away from the equals. which is a very,
How do you know whether that was a good performance against a poor performance?
I don't.
So that you see, yeah, it's not relative really, is it, to each project?
It's the only data I have.
It's just an average, isn't it? So
Yeah. So well, each one of these is a project.
Yeah.
Each one of those is a
it
project.
might have been executed really well.
Yep.
That's why it's come under.
Yep.
So the functional steps could be equivalent to another project. The fact that it's come under it, it's just managed better. You just can't, yeah.
But doesn't that kind of function points, doesn't that mean the function points are intrinsically inaccurate to some degree? Because, because, okay, as you say, you could have a project with people on it are not very good, and another project where they're really good. And the same number of function points, but one does really well and the other one doesn't. It's the people thing. Function points.
How's a function point scope then? What is the?
It's about it's about the business value. There are various things you count in the requirements and the business the inputs and the outputs. It doesn't take account of the people doing the work. So they don't say, well, if you put someone rubbish on it, it'll take this long. And if you put someone good on it, it'll take that long. They don't know.
Those are the fiddle factors that come later.
Yeah.
Yeah, I mean, BIM specifically identifies things like unstable platforms, untrained teams and so forth as giving you a multiple of your original estimate.
Yeah, it's very, yeah, okay. So that's function points. This is story points. So story points, developers hate estimating in time. So what are you going to estimate in? Well, you're going to estimate in story points. Essentially, they're monopoly money. So it's like a psychological safe way of estimating. You have these things called story points. Well, what exactly are? They're not time. No. I've been blocked on lots of groups by calling them time and saying they are time. No. They're not supposed to be time, and they're not time. So what happens if people pick a number? 6. Actually, you pick one of these numbers. You're supposed to pick one of those numbers. We think this is a 2. And the claim is that over time, people will get a rough feel for how much implementation efforts involved in a particular task, so that individuals will be consistent. So if I think something's a 3, I'm probably going to think related kinds of things are 3s or 8s or whatever's. So the idea is over time, individuals are consistent. And the other claim is when teams work together, we have meetings and say, I think this is a 3. He says, no, that's a 5. And we have a discussion. The idea is over time that teams will converge and will be consistent. And everyone on the team will say, yes, that's an 8. And they'll sort of agree it's an 8. And then the idea is you get mapping, you get data on actual times. So you've been doing story points for sort of like 6 months, and you have a whole database full of story points, estimates, actual time. But story points are not time. So yeah, and you're supposed to use this database to do what if it's not time?
Well, the velocity, calculate velocity from the story points. That's what it's for, isn't it? When you're talking about
Velocity in time.
well, I suppose it's how many story points a team can do in a sprint or a block of time.
Which is time. But story points are not time.
Yeah, but I think it's the idea that you like look at it retrospectively. And then you see,
Oh yeah, so you have a 2-week sprint and you got so many story points in a sprint. But doesn't that mean that story points are actually time?
well, yeah, so it depends as well. I think they've got other benefits. So like what you were saying about converging,
Yeah.
people can come up with better solutions, can't they?
Well, if you keep estimating 20 story points, that kind of suggests that the task hasn't been broken down into smaller components. So lots of 13s and 20s is kind of a bad sign that you're not breaking things up into smaller. So the idea of estimating a story point is numbers are all supposed to be down here.
Yeah.
Rather than up there. So that's the one good side of story points of making you think, well, and they do make you think about, well, roughly how much work is there? But there's a whole ritualized thing around this, and you're supposed to do Fibonacci numbers, but people try, yeah.
If, so we would have, if a project was very urgent, then it would get higher points because more time along the 2-week sprint would have to be put, like, you might have to put a lot of time and nothing else has happened but that project.
But if let's say you've got a project and it totals up to 100 story points.
It has to be within you can't have more points in time in hours in the 2 weeks.
But you might put multiple teams on it.
Sorry?
You might have multiple teams running up, run.
True, yes, yeah, and from that point of view, because it's from the team, not the people who you get
Yeah,
independence
so
from.
you have multiple 2-week sprints spread across multiple teams, yeah.
The leader would have the highest, yeah.
That's right, yeah.
Are people in their minds picking a number based on a notion of complexity of the task?
Complexity is another term that comes up. They say, well, more story points is more complex. Yeah, people talk about that. And you say, well, how do you measure it? There are all sorts of awkward questions you can ask about this. And if you push people too much, they block you and walk away and don't like you. It's supposed to be, the thing is, it seems to work. Sorry.
Yeah, I can give you for instance, from a project I've just finished working on, which was, I was engaged for about 18 months on that. And, you know, to begin with, teams would just estimate the number of stories. And we sort of assumed that stories are more or less all the same. We came to realize that that's not the case, and you know, some things were inherently more complex and couldn't be broken down small enough to be meaningful. So then we started doing these estimates, and we just picked a sort of scale, as you say. The biggest story we allowed was 13 in a sprint, because that would more or less take up the entire sprint. And gradually we got to feel the velocity of the team, and you know, later on they all decided, no, we can't do more than 8 in a sprint. It has to be broken down further. So you got some sort of an intuitive feel over time as to what a story point equates to.
It's very easy to mock it, and I do, but it works. It does work. There are teams using this, and I've got some data here, and they roughly have a story points an hour, and it's time, but yeah, and story points work. So yeah.
They do for agile projects that have got a kind of continuous delivery, incremental delivery type of model. If you're faced with having to give a fixed price estimate for a complete system, there's no use at all.
Yeah, it's frustrating. It works. It does still, and people don't use the Fibonacci, and you get decimal points. Like people estimate 3.5. Yeah, they do. So you can mock it, but it works. There are teams using it, and they produce stuff, and it kind of yeah.
I had a bone to pick with my team about Fibonacci numbers, because they said they really misunderstood the way that you do these stories, and they would only assign numbers in that series to a story. What it actually means is any one individual doing the estimating should be using numbers on their series, because you have a feeling whether it's a tiny story, small, medium or large. But you then use the Monte Carlo model to come to an average, which, as you say, can have decimal numbers in.
I tend to find that the novice teams, they stick to these numbers, and then the more people have been doing it for a while, they kind of pick other numbers. Yes, I've got some data with estimates, but I've got I've only got one data set where I've got the actuals. So that's the only comparison I have. Again, it's one data set. So yes, 2019. So it says post 2019 explosion. I happened to be sitting next to someone in a workshop, and I was telling him, "Oh, it's terrible. We don't have any software estimation data." And he started this company, sorry, that should be a capital C there, Software in Partnership. He'd been running this company for 10 years and sold it. And they'd estimated everything and recorded it all, and they had actuals, and they had everything. And he had 10,100 unique tasks. And yes, I could have it and make it public. It's like, what? It's completely unbelievable. 22 developers, 20 internal projects, da-di-da-di-da. So instantly, 2 orders of magnitude more data than had previously existed became public. So that was in 2019. 2021, I found an even bigger data set. Where did that come from? 61,000 tasks. These were 45 separate projects. So this was one company's data set. This was 45 external, actually military contracts. And the first talk I gave on this data set was organized by Renzo. And after the talk, he said, well, I got some data as well. I got some Pomodoro data, about 9-10 years apart, and you can have it if you want. You know that data. So all of a sudden, tools are making more data. This is agile data, small tasks. We can finally build some good models. So what did I find out? This is just a summary. So the findings were not software specific. They were really human. It's about human characteristics. People use round numbers. I'll say something about those. Some people call them heaping. You have individuals that are consistently over or underestimating. I'll talk about accuracy and waiting time. So round numbers. What's a round number? The idea behind a round number is you want to communicate an approximate value. If I say it's going to happen in an hour, you've got a rough idea of what I'm talking about. If I say it's going to take an hour and 15 minutes, then it's kind of a more accurate value. So your leeway on a 1 hour, 15 minutes is your bounds on that is smaller. So and you have cultural work influences. People tend to estimate a day rather than slightly under a day or over a day. So when you look at people estimating in hours, they tend to estimate 7 hours because they work a 7-hour day, or 4 hours because that's half a day. You don't see many 6-hour estimates, and you don't see many 8-hour estimates. It's 7 hours. Tend to be divisible by 2, 5, or powers of 10. Again, these are round numbers. So this is a data set. So this is the estimate in minutes for a task, and this is how many tasks there were. So you see lots of 1 hour tasks, 2 hour tasks, 4 hour tasks, 30 minutes, 1 day, 2 days, 5 days, 3 days, 5 days, and bits and pieces in between. So you can see that people are estimating in round numbers. Like 90 minutes down here is an hour and a half, but they're more likely to estimate 2 hours. 1 day, there's 6 hours. So people are not estimating as many tasks as 6 hours, but a lot more as 1 day. And 8 hours is sort of somewhere down here, somewhere or other. So people are estimating in round numbers. And this is very common. This replicates over lots and lots of data, lots of projects. People estimating in round numbers. One of the data sets I looked at, there were lots of 1 hour estimates. And I said, well, the way you can make more accurate estimates is to change that 1 hour into 1 hour, 15 minutes. But of course, they didn't want to estimate 1 hour, 15 minutes because that would suggest that they were being more accurate. But in fact, an hour was roughly what they thought. So they didn't want to increase the accuracy of their estimation by giving an extra bit in there, by reducing uncertainty. So this is round numbers. Sorry, where am I going? So that's a total of 1,900 tasks estimated there. So you see this a lot. So we were talking about Fibonacci numbers. You see that those peaks were there. If you take the maximum round numbers, the peaks, and you plot them in numeric order, you get the same pattern as you do for the Fibonacci numbers. This line here, these are the Fibonacci numbers, the ratios. And these are ratios from projects where people were estimating time by looking at the peaks of the round numbers. So in other words, when you give people the opportunity to estimate in time and they can pick any number they like, they actually tend to choose round numbers that have the same, are in the same scale ratio as the Fibonacci numbers, which I found very surprising. Because I used to think, oh, Fibonacci numbers, that's just a sort of gimmick. But actually, it isn't. It corresponds to, that's an exponential bit there. You can see here. Yeah. So the Fibonacci ratio is applicable. It's just sliding it down slightly. Yes. Some people consistently overestimate, some people consistently underestimate. These are people, this is just an anonymous ID. So these people were consistently estimating too much, a factor of 2 over. These people were consistently underestimating. This person here, whoever he was, or she, was consistently underestimating. You'll find when you look at individuals and you pull out the data, that people are either under or over. I spoke to the director of SIP when I told him who was over and who was under. So the under people tend to have a sort of salesman personality. They're willing to take risks. They want to get things done. They tend to underestimate. And the people who overestimate tend to be the cautious employees. Well, I'm not certain. They tend to overestimate. Now, when I saw this data, I thought, yes, I've made a discovery. This is something useful to tell companies. I can say, look, so-and-so's over, so-and-so's under, send them on a course. So you'll shift the unders up and the overs down. And all the managers I've spoken to said, don't want to do that. Why don't want to do that? Because they don't want to upset their developers. They don't want to call developers out saying, oh, you're over, you're under, go on a course. They don't want to do that. They don't want to upset their developers. So here's this wonderful discovery I've made, and it's of no use because managers are not going to send people on the course to shift their estimates one way or the other. I have the evidence, like, yep.
Couldn't you deal with that just by noting if person number 1 is always estimating 80%, then every time he gives 80%, you just add 20% on to knock it up. And similarly for the overestimates.
They're probably doing that already. Because when I identified the people, that the manager said, yes, I know him, and he does do that. And so, yes, really, I'm telling people things they already know. Managers already know who's under, who's over. At least the experienced managers do. The new guy on the job won't know. But yes, that's true. So in a sense, I'm not telling them anything new, but I'm putting numbers to it. So this is over under. So this idea that everybody underestimates is not true. There are people who overestimate. And I'll come on to that in a minute. So if we plot estimate against actual, this actually is for road surfacing tasks. What we expect the data to look like this. So that grey line there is where the estimate is the same as the actual. And anything above that line, they're underestimating. I know it's the wrong way around, but so these are, this is data from is it 700? So yeah, 746 road construction projects. And each one of those pluses is a bid. So that's what we expect it to look like. Companies are bidding on a job and they've underestimated to get the job. And it's quite accurate. In fact, they've underestimated on average by 24%. Seems to be like the industry average in that part of the world. That's a fitted regression line to the data. So people, and as I said, that grey line. So there are a few companies who've overestimated, but there aren't very many of them. 1, 2, 3, 6, 7, 8, 9, 10 out of that 700 have actually overestimated. But everybody else is underestimated to get the work by some amount. So that's road construction. Would anybody like to guess what software data looks like? Estimation data? Does it look like this? How you'd expect it, where people are consistently underestimating? So this is what software data looks like. So that grey line there that you can't really see is where estimate equals actual. So some people are overestimating, some people are underestimating. It's all over the place. And that pattern occurs all over the place. That red line is a regression fit. Everything between those two purple lines is within a factor of 2. Everything between those two yellow lines is within a factor of 4. Either over or under. So 30% are accurate, 66% of tasks within a factor of 2, and 95% within a factor of 4.
Reading beyond that.
And when an early presentation, I showed this to a VC manager, funder. He said, "Oh, that's quite good. I'm quite happy with that." I was quite shocked. Factor of 4.
My friend Keith Braithwaite saw something similar to this in his experience, that basically when you're trying to estimate a software project.
These are tasks. These are 1 hour, 2 hours.
Tasks. Yes. But even, he said if people are estimating a software project, they're essentially putting their finger in the air and testing the wind. So he would say to the business, you haven't got a business case for doing this unless the payback is at least 4 times your outlay. Because if it's marginal within that, you're risking losing money.
And this pattern of 30, 66, that occurs for function points, and that occurs for other projects. This is one particular project. This occurs for the 47 separate distinct seesaw projects. The numbers change by 1 or 2, and the factor of 2 might be 2.1 or 1.9, but it keeps occurring again and again and again. Factor of 2, factor of 4. And the function point stuff is the same from that one data set. And my other data sets might be better. So, and people I talk to, like you just said, kind of going, yeah, sounds about right. So they're not shocked. I think the surprising thing that the people are overestimating, but that happens. So it's not like this model where everybody, this model is showing that they have a very good, accurate model of prediction, and that they can actually reliably underestimate. They're very reliable. So road surfacing work, they can reliably underestimate. They're very good at it. And you can see how narrow that line is. So they're actually very good at it. Whereas in the software world, it's much wider and people are over and under. So in the software world, the accuracy is just all over the place. There isn't a good model. Yeah, so factor of 2, factor of 4. And again, the slope of that line, you'll see that people are underestimating on short tasks, overestimating on long tasks. And I think that's a resource that if someone comes in and asks you, and they say, well, how long is this going to take? And you think it's only going to take an hour. How long are you going to how much time are you going to spend estimating? If it's only going to take an hour, you're not going to spend half an hour thinking about it. And so
I worked for one project where that happened.
And so because you're not thinking about it, you're missing all the peculiar things that might happen. And you're probably going to underestimate, and they do. Whereas for a longer project, if I ask you to do a job and you think it's going to take a week, you might spend an hour or 2 thinking about it. So you'll work out what could go wrong, and you're going to be careful about it, and you're probably going to overestimate. And in fact, that's what happens in practice. Okay. Oh, this is task waiting time. So tasks go into a queue in the agile world, and how long do tasks sit in the queue? And it's a power law. I thought this was a major discovery, another major discovery I'd found. And it turns out if you have a priority queue, that the items in a priority queue, the waiting time is a power law. So I was very disappointed when I found that out, because I thought I made a major discovery. There's something unknown. Of course, when you tell people it's a priority queue, they're kind of going, yeah, of course we're using a priority queue. So another major non-discovery. It's a priority queue. You get a power law for waiting times. So really, software estimation research has only just started, because we've only just acquired the data. We can only just start building reliable models. I think the patterns of behavior are human-driven. They're not specific to software. There's intrinsic uncertainty, and many development teams don't estimate anyway. So even if I had a magic formula I could tell you, most people wouldn't be able to use it because they don't measure anything, and therefore the formula is no good to them. So that's the summary of where the research is today. So I collect this is a request for data. I collect software engineering data. So if you know of any software engineering data, I offer to do a free analysis of that data, provided you'll let me make an anonymous version of that data public. Publish up my blog, I talk about it, and so on. There's an example, Renzo's data. Contact me here. Yes, so data is very rare. Yeah, it tends to be small companies. Large companies have lawyers, and lawyers like saying no. So I've spoken to several companies, and then the lawyers have got involved. So if you've got a company under 50 people, a company under 50 people, they probably don't have lawyers. You can talk to the people in charge. You can help them. You can show what's going on, help them to understand the processes, and I get some data which I can talk about. And that's it. That's the last slide. Yes, 29. Oh, thank you very much.
Another question from the floor here. Unfortunately, it's a bit out of time now because about 5 minutes ago, Arto asked, that is perhaps a difference of 2,000 years of practice versus 50 to 70 years of practice. I'm not sure what it's referring to.
It could be the road building example.
Oh, yeah, because people have been building roads for many thousands of years, yes.
Yes. But I don't know how long they've been collecting data. I imagine the Romans were very good at collecting data on how long it took to build a road. Imagine there's some researchers somewhere. But in the software world, people just don't measure. They don't, and when they do measure, they don't hang on to the data. The most common response I get when I ask people about data is, why do you want data? What are you going to do with it? Is it useful? This idea that you can discover what's going on, understand your processes by looking at the data. People don't have that outlook. I guess because there's so much benefit in software and companies are willing to pay for whatever it takes. Why use a scientific approach? You don't need to. Companies can get away with charging whatever, doing whatever. The scientific approach is not needed, not yet anyway. Perhaps in 30 years' time might be true.
So what software estimation technique would you recommend?
I wouldn't recommend any. Well, just practical experience. I don't know any of them that work or don't work. There are people who can do it and there are people who can't do it. So practice, I guess, is you just practice doing it. The more practice if you think, oh, it's going to take an hour, and then you record how long it takes, you estimate an hour, and then you record how long it actually takes. You learn something from that, and then the next job you do the same again. And you keep practicing, you'll get better. But there are always uncertainties and interruptions. Yeah, it's intrinsically an uncertain business.
Isn't that the case with software development? Because physically you don't have any reliable data sets to compare against. When you're developing software, you're developing something new that you're not developing like manufacturing, producing widgets again. You're doing something quite different, and therefore there will be that gap, that wider gap that you illustrated.
For instance, when I was in the compiler business, after a while you think, oh yeah, this is how it works, this is how long it's going to take. Because I'd written enough compilers or bits of compilers, I knew, but people who hadn't done that couldn't say that, and they didn't, and they would completely underestimate or overestimate. So it was only my experience of having done it multiple times for different languages, I could produce a sort of semi-reliable estimate. I became confident. So, and a lot of software is redoing what's been previously done, which is why LLMs work so well, because they go and look at, well, what's that? What the question you're asking has probably been done multiple times, and they can find where it's been done and give you the code. That's why they work so well. A lot of code is very boring. It's just repetition of what's already been done. So there's very little new. It might be new to the person doing it. So, and the person doing it might be the person making the estimate. They haven't done it before. So you're
asking the wrong person.
You're asking the wrong person.
Point estimate, because he will think it's simple, and the person doing it will be quite a noise to it. And that's where you get that difference. Anyway.
Which is why if you're estimating a large, expensive project, you have experienced people, And then the smaller stuff, where the risk of being seriously wrong doesn't matter too much, you give to the less experienced people.
Just checked, and the pizza is going to be out for delivery shortly.
Okay.
So we can carry on talking for about 5 to 10 minutes, I should think, before it gets here.
Okay.
I'm interested in your idea of dumping out a Jira repository.
Yeah.
What sort of information do you get from that?
Some Jira repos, well, I'm really after Jira repos with estimates in them, and there are some. The getting info out of Jira repos is difficult because people tend to chop and change, they get reorganized, new issues get created, new milestones and this, that, and the other. But yeah, you can find estimates in there, and so it's a matter of getting hold of estimates. There are things you can do like measure the time between milestones. Sometimes people will have multiple milestones. They won't just record the fact that, oh, it was created and then done, which virtually tells you nothing. They'll have intermediate steps, and you can build a model on the intermediate steps, assuming those steps don't get moved around, which sometimes they do.
What I find with tickets and Jira, they've always got fields where you can fill in actual time expended and all that kind of stuff. Nobody ever does. So do you actually work off the time when a task was begun and ended, that kind of thing?
Sometimes people do, a subset of people do fill in done times. It's a small, as you can tell, the data is so hard to find that I'll take anything, really, because it's so hard. You can get, if a project is divided into multiple stages, you can measure time in stage. So you can measure transition probabilities, which is something. But you run the risk of the stages get added and removed. And so you're not really quite certain, are you really measuring the same stages all the time? Yeah, and a lot of people just, as you say, they have created done with no intermediate stages, and that really tells you nothing.
Most projects I work on use the sort of Kanban style board within a sprint to move stories along. Yeah, I'm just interested about the confidentiality side of things. I mean, would you provide a toolkit to anonymize the data?
Yeah, it's easy because you want to anonymize things like developer ID.
Yes.
You want to so you call D1, D2, D3, D4. You want to anonymize the project ID, so you have P1, P2, P3, P4. Remove all the cost data because nobody ever. So you can chop it all up. So certain keywords you might want to turn into XXX because they provide identifying information. It's really I'm not so much interested in text because text is so difficult to analyze anyway. It's really time. Time is the thing. How long do you think spend in different time? It's the time issue. People want transition matrix. How long does something spend in this and then goes to that and so on. And the other issue is, well, what questions do people want to ask? So, I mean, I would ask you, if I had software estimation data, what questions would you like to ask of the data? Because one of the problems I have is coming up with the right questions to ask. So I've made these discoveries and people are going, yeah, okay, fine, yeah, whatever. So I haven't yet hit on the right questions to ask, perhaps because I don't have the right data. Well, that's said, what is a good estimation technique? Well, that's kind of so nebulous that you can't really say one way or the other. So if you have timing data, what would you want to know? So managers might be interested in how long does something spend in this state rather than that state. How frequently do they transition? Next question is, well, how long? What can you do about it? Well, this is another question. The other thing to do with Scrum, when you have sprints, someone's asking about sprints, is how many sprints does a story occur in before it's actually done? Because if a sprint is completed without a story being implemented, it goes into the next sprint and so on. And that tends to be a power law. So there's a certain percentage, and that works out. You can predict that quite well. Certain percentage go to the next sprint and then the next sprint. I think that's a square root power law, he says. Yeah, so it's like 1 over x to minus 2 is the probability that it will go into multiple x sprints. He says off the top. If you look on my blog, the analysis is on. If you look on sprint backlog, there's an article analysing some data that tells you.
Yeah, I mean, my recent project, we had one story which the guy who took it on was so apologetic because it just said, make all the user acceptance tests work. And it was estimated at 5 points or something. It went on for about 8 sprints.
Yeah, as you mentioned earlier about the line of code. So I have one of the question about the line of code. So what kind of criteria do you set for the one line of code, like one of the previous languages like Java? And if you wanna implement the project, a module in Java, it takes many lines to implementation, right? But the new tech stack, it takes less line of code. So how can we estimate the cost? How many lines gonna come on that, and how many at previous languages have just 1 line of code, like attribute and anything. So on how many words or characters gonna come on the one line of code? Can you is there any criteria for that?
Yes, there are some studies comparing if you write in different languages, on average, how many lines of code difference would you expect?
Yeah.
And there are some published numbers that say in such a language, like assembler, you'd expect many more lines of code in assembler than you would in a high-level language. And there are some tables that tell you that. So one of the inputs to these models is the line of code. Is the language. So what language are you programming in? And that will modify the line of code estimate. Because certainly the early military projects, a lot of them were in assembler, so that there were many, many lines of code. And you're comparing, say, Fortran with COBOL, and languages like that, you'd expect different numbers of lines of code. And then you have the question, well, what is a line of code? Do you cut out blank lines? Some formula only count executable lines, so they ignore comments and they ignore blank lines. So and they ignore declarations as well, only executable lines. So you normally see, rather than lock, LOK, you see ELOC, executable lines of code, or ESLOC, executable source lines of code. So that there are different ways of measuring things. Yeah. But lines of code, it's not as popular these days as a metric.
Yeah.
People have started to realise actually lines of code. But lots of things do correlate with lines of code, or rather they correlate with the log of lines of code. The log of the number of lines of code correlates wonderfully with all sorts of things. It's kind of, okay.
Nice.
Do large open source projects and the repositories that they're hosted on offer any opportunities for data? Things like this piece of code was checked out, worked on, checked back in. This is how many changes happened.
There's a whole industry of people working, researchers looking at open source code because it's all suddenly available. And so about 2005, that whole software, evidence-based software engineering, just because of GitHub, it was all there on GitHub. So that happened about 2005. So there's all sorts of supposed findings. And when people dug into it, the data is very noisy. So for instance, you look at bug reports, how long does it take to get a bug report? About 40% of bug reports are actually requests for enhancement. Now you can say a missing feature is a bug, but it's not a mistake in the code. And then you've got issues of duplicate bug reports. So it takes a lot of work to go into a project and separate out the requests for enhancement from the duplicates. One of the beauties of commercial databases is that they've already done that kind of work. They've separated out the real bugs from the requests for enhancements, and they've sorted out all the duplicates. And that tends not to happen in open source projects, or it happens eventually, but you have very, very noisy data. And open source projects tend not to estimate, some do, or some people on some projects do, but not very, very many.
Even for the planned development. So I'm thinking something like, say, LibreOffice or OpenOffice, they would have planned development cycles and new releases where that wouldn't be as unstructured as all these bug reports and things. But
Well, I don't recall looking at their data, but I know Mozilla doesn't. I would tar them with the same brush as everybody else saying they don't, because so many people don't do it, I would guess they don't. But you know, I may be wrong on that. If they did, they're sufficiently well known, I'd probably know about it. It's like, oh, look, data, yeah. I tend to find data in very obscure places. Yeah, you read a paper and then you get to the back and go, oh, look at that. I read one Chinese paper. Just flicking, I read, even though they're in Chinese and I don't read Chinese, I skip through looking at the diagrams. And I was skipping through one Chinese paper. And I looked at the diagram and I knew exactly what it was. Wow, look at that. And I used Google Translate to translate what it was about. Yes, it really is. And I emailed them saying, can I have this data? And it was actually cost data by phases. How much data, how much they spent on requirements, design, coding, this, that, and the other. And I think it was about 2,000 projects. It was like 2,000 projects. It's the only data set of its kind. So I emailed him saying, oh, I've read your paper, even though I don't speak Chinese. Can I have your data? And he said, yes. It's like, what? And it's in the book and you can go and get it. So it's the only data of its kind. Yeah. So it's a very strange place to find it, reading in a Chinese paper, seeing the plot and saying, I know what that plot is. And then using Google Translate to figure it out, you email them. About a third of the people I email, they just ignore my emails. About a third of the people I email, they say it's on my old laptop. In other words, it's gone. The data. And about a third of people say, yeah, here's the data. Great. Including the Chinese one. I'm sure there's lots of stuff in India as well, but the Indians don't publish many papers, which is very annoying. Well, the papers they publish, most of them are just sort of really like, not very good. But yeah, I'm sure there's lots of data somewhere in India, but I don't speak any of the Indian languages. Yeah.
another question then, on the factor of 4 thing, plus and minus, it makes me think of scenarios where I've had managers who really try to play down and underestimate because of say they're trying to secure a slice of this year's budget and they don't want it to be too big because
exactly,
it will compromise them. But then after you've done it, say you're a vendor and you're trying to sell software, you're going to say, oh, you know, we're charging you £50,000 for this software, but it's 8 million lines of code and this and that and the other. So they grossly inflate it. So is there any way of separating out those different agendas that are driving over and under?
Well, everybody seems to like well, not everybody, but managers who want to do a project will under, because to get, as you say, the budget, they have to get under to get the money. And some people, so yeah, there is a kind of willingness for everybody to be under. There are some people who say, no, I'm going to stick to this and that's all the money I have. And there are some people who want accurate numbers. I'm very unhappy with not having accurate numbers. Yeah. The people who are paying real money tend to want accurate numbers. Well, don't we all want accurate numbers? We get the plumber come round, you say, well, how much is it going to cost? And you want some accurate estimate for your plumbing job or your whatever job. Everybody wants a decent estimate. In the software world, we're special, we don't do estimates.
But does the truth carry any weight, or is it actually one set of lies carries weight for one scenario and another set of lies carries weight for another, and the truth gets lost?
Yeah. The boring thing, yeah. Realities, yeah.
We've got to bring this to a stop because the food's here. Let's carry on discussing out there, and let's thank Derek for a very interesting talk.